All right. Good morning, Evgeny.
Hello, good morning, good day, Rami.
Yes. So we wanted to talk about AI a little bit. I think you understand better what you wanted to talk about than I do. You watched something I did with somebody about AI, and you had some comments about it. Why don't you tell me or tell us what it is that you wanted to talk to us about today?
Yeah, well, so it's great to be back at the podcast with you. We had a great one last time about Eli Goldratt, and I mentioned back then that I'm more of a technical person. So wherever I try to evaluate something, I'm trying to look into the technicalities of how it works. And for example, most people today they are aware that AI exists. They have maybe even used it because of all the hype around the ChatGPT, I guess. But today there's a lot of competitors as well, so everybody's checking them out. But when people try to explain AI to each other, they often use anthropomorphic kind of explanations. They try to understand it using intuition about what humans would do, and I don't really think it's productive because it's a different thing and it's much more technical. And if we try to develop an intuition about how it actually does what it does, then maybe we can use it better. Or you know, that's my kind of um,
Yeah, I think people are trying to describe AI by saying, okay, is it going to be sentient? And then the way they define sentience is it human? Does it have all
yeah,
the features that they think are human? And
exactly.
then if you're missing one or two of those features, then they say you're not human or not sentient and not really the AGI that people are looking
I,
for.
and it doesn't help that they call it artificial intelligence as if it's actual intelligence or so anyway, so I wanted to when I watched you discuss and mention this in this way with your other uh, podcast partner, I guess. Well, I thought maybe we should talk about the actual technical stuff, and I'm really good at that, so I could maybe explain how it actually technically works, and we could discuss a little bit about that.
Yeah.
What do you say?
Yeah, let's do it.
Okay, so if any of the viewers are physicists or mathematicians, they would be right at home here because I see you smiling. So if we go to the very beginning of how it works, how this thing we call AI works, it's very it's just a linear algebra, right? It's just matrices and vectors and multiplication of matrices and all that kind of thing. That's what's happening behind the scenes. Now, the interesting so if I add a little bit more color to this, what happens is you have some kind of input. The input could be an image, it could be voice. We have models today that can parse images and tell you what they see. They can read text and somehow understand what it means. They could listen to someone and understand what words he is using, right? Well, understand is a weird word to use here, but anyway. So what happens is that whatever the input is, it is being turned into numbers. So we can, as input, we can give it anything. Doesn't really matter. And the first step is you turn it into numbers. And they usually called tokens. And then these numbers are multiplied, or they go through a process of multiple matrix multiplications with these matrices that are full of numbers. And at the other side, you get numbers out. And that's it. So that's the whole process. Now, what you can do with this is you can train. And what does training means? You can change these internal matrices, you can change their numbers so that whenever you give it some input, the output is what you expect to get. So if I use, for example, a speech recognition model and I speak a word and I expect on the other side to see written text, which says word, WORD, yeah? So at first it will not do that because the matrices are just zeros. But then I start changing the numbers in the matrices and change them again and change them again. And each time I can evaluate, that's the professional term for it, I can evaluate how close is the result to the result I'm expecting. So how close is the output to the text word? And from this, you can kind of understand that it takes forever to do this, because it's like, like little children when they want to multiply numbers or add or sum numbers, they guess.
Brute force method, try all the things, and then hopefully you land on the right one early on in the process.
And the only savior here is that you can evaluate, you can kind of measure how close are you to the thing that a human would expect as output. So we can tweak it in the direction of the correct guesses. And that's it. That's how it works. On the very, the essence of it. Okay, so if you have any questions about this.
I don't have any questions. I understood all that from previous, yeah.
Well,
it's really interesting because a lot of what you said in the past was never called AI. This AI term came out afterwards, and as this process got more and more advanced, we, I guess, started to call it artificial intelligence.
Well, the thing that happened here is that when you have all of these big matrices multiplying and creating results, the magic that happened here is that there's an emerging property for this. We didn't expect that just multiplying numbers can recognize objects and images. We didn't expect that just multiplying numbers can recognize speech or can produce images from textual descriptions. And what happened is that we made these models bigger and bigger and bigger and bigger. Basically, we made these matrices huge. They have billions of numbers in them.
Dimensions.
And it turns out that the results we are getting are improving. And everybody was pretty much surprised by this, because all of this was tried in the 60s and 70s, and it was dismissed because that will never work. But actually it does. Yeah, it will always produce bad results. Like, the results are never going to be perfect. But what happened is that perfect doesn't really matter, because close enough to perfect is already so much more than anyone ever expected.
And our standards can keep getting better, and we can keep getting closer.
Exactly. But another thing and another aspect I want to talk about is the possibility of actually doing this. So again, back in the 60s, we didn't really have, we already had computers, or 70s, 80s, even 90s. We already had computers that were much more powerful than the first computers or the first calculators. But they were still not powerful enough, or so underpowered compared to the task at hand, that nobody imagined they would be able to use these huge matrices of hundreds of billions of parameters. And what results is, sometime in the late 90s, I think, maybe early 2000s, there was this other problem in computing that was in computer graphics. So games became more and more popular, and people wanted to pay more and more money for games to play on the computer. And the developers of the games, they wanted the graphics to be better and better. And then you had something emerging that is called the graphics card. And what the graphic card allows you is to multiply many, many numbers in parallel at the same time. And this was not the architecture of CPUs that existed before. Even today, you have your CPU in the computer. It can multiply numbers, but it cannot multiply billions of numbers simultaneously in parallel and then give you the result. And that's why right now you see companies like NVIDIA are getting just on the stock market, they're in bubble territory, because it's just incredible that this thing that is called multiplying numbers in parallel is so important for this new AI wave, that these companies, they get valuations like, it's completely crazy what's going on in there. And this new, it's not new, but this model of computation, having many very very small calculators calculating together at the same time but separately, this is the thing that enabled to have bigger and bigger matrices. And if you're looking at in the future, we'll probably have even faster and even smaller transistors, and even faster compute units that can computate all of this. So we can expect AI to get exponentially better than what it is right now.
It's not just getting smaller. Now we have quantum computing.
Well, so not really.
That, according to David Deutsch and the big companies that are implementing this technology, they do.
Well, we have the principle of quantum computing, and we have a very small number of qubits, which are these quantum bits. The regular bit in the computer is implemented physically using a transistor, and the transistor has maybe 3 states. It can either conduct or not conduct, or be somewhere in the middle. But these qubits, they have infinite amount of states, and then whenever you actually look at it, like Schrodinger's cat, whenever you actually look at it, then you know what the state is. But the thing is, these are still in their infancy. It's nothing that can actually be used anywhere at the moment. But
I heard it was actually already commercialized, and the big companies are using them, but I don't really know.
Yeah, not really. But the what's it called? The Moore's law. Okay, Moore's law, which is I believe it was the CEO of Intel back at the day. He said that every 2 years the number of transistors on a chip is going to double, and so far it has been correct, the law, and that's why we see every couple of years our devices are becoming more and more powerful in terms of what they can do, how fast they can do it. And with this new challenge put before them, the challenge of increasing the parallel computation of numbers, it's just going to improve. Now, the thing with AI models today, and that is pretty limiting, is that there's still snapshots. The matrix doesn't change. So when you go to ChatGPT and you use it, every time you use it, it is still the exact same matrix of numbers. It doesn't actually change as you talk to it. Now, we humans, as you explain concepts to us, we constantly change, we constantly learn, we change our opinions.
Some of us, yeah.
It's a difficult process, but there's a lot of impedance, there's a lot of resistance to changing opinions in humans. Not in all of them. We discussed this in our previous podcast. It's possible to open your mind a little, but computers don't have this limitation. They don't mind changing, but there is a constraint here. As I explained before, the training part of a model is like guesswork. It takes much longer, much more resource intense. You have to basically brute force a lot of trials before you get somewhere that is closer to a good result. But inference, which is the part where we just use the model, we just give it the inputs and it gives us the calculation result, that is basically cheap. So that is coming to devices, to our phones, to, I don't know, our refrigerator LCD panels. It's going to come to smaller and smaller devices, and very dumb devices that don't really have very expensive processing units in them. But the training part, when you are talking about real intelligence, When you're talking about a robot that helps you around the house and it already knows how to wash the dishes and wash the floor and everything, you can only say that it is becoming intelligent if the training is done inside of that robot. The more you interact with it, the more it learns about you. And we are still quite far away from that. We're still not there. So even though we have like amazing AI today, we're not yet in the train on your device territory. There's something called fine-tuning, which is you take a big model that is already trained and you tweak it a little bit, and that is already very expensive. But to tweak it a lot, it's so expensive, it's not yet feasible to do for most people on their devices. It cannot be done in huge data centers. And I think in the future, that is going to be really interesting because that is definitely coming. There's no way that training is not coming to our devices. It is. We're not there yet, but it is. At the moment, what is happening in the field of AI is everybody's trying to find optimizations. How can we do less computation in order to get better and better evaluated results? So how can we, for example, one example of this is called quantization. So if you have a matrix of really big numbers, they're real numbers. They're numbers that have many digits before the dot and many digits after the dot. So in computers, you have to represent numbers as bits, as transistor values, on or off. And you have a limited amount of bits for each such value. So what you can do is you can reduce the number of bits. So you lose in the precision of the number becomes less precise, maybe not dot 6666665, maybe just dot 66, and that's it. But it turns out that the model runs faster because you need to compute less bits, and it is good enough. It is still getting out from inference, you still get really good results. So this is one of the ways that people have optimized these very smart models that have been trained for it costs billions of dollars to train these models. And then, for example, Facebook, the Meta, the company, they just give them to you for free to use. You can just download them from the internet and you can run them on your computer if your computer is slightly better than average. And you get to use something that has cost them billions of dollars to use. It's absolutely mind-boggling what's happening right now. And also you have all of these services like OpenAI and all the others, Perplexity, Anthropic, all the cloud providers like Amazon, AWS, and Google. They give you places where you can run all this. Google is going really heavy into the AI stuff. They all give you access to technology, to these models. It costs them a fortune to create, and we don't really do much with them at the moment that is bringing out a fortune of value back. So the ROI is, people are still looking for where's the return on the investment. The investment has been huge, but the return has not yet been so great. There's been a lot of hype, a lot of bubbly.
But it's hard to know how this is going to be taken advantage of.
Yeah. So that's the.
Do you have ideas on like where everyone's lacking and how we can maximize the potential value more?
Well, as I said, I think whenever somebody figures out how to make processors that can train on devices, that is going to be huge. At the moment, what's happening is that these models, they've been trained and they know language quite well. Because the models that became really, really popular are the language models, but because everybody's using them. But there are also more niche models like image generation and video generation, which is coming to a cinema near you real soon now. So you'll have movies that are completely fictional, made with characters that don't have an actor behind them, rendered on the computer, and you wouldn't really know the difference. It's already happening. It already happened. But the thing is, At the moment, these models, as I said, are snapshots. You create the model, and then it can do what it can do. And if you want to improve on it, you need to train a derivative, a better model. And the training is very expensive. But the way that people found they can augment this, they're starting to give these models, they're starting to give them agency. And that is already being done, but it's going to increase. So what is agency? Agency is where the model can interact with the outside world, and it can request additional information so that its input into the model is better. For example, one such technique is called retrieval augmented generation, or RAG. What happens there is that you send a question to the model in text, and before the actual AI model gets your question, there's a process that goes to the internet, brings in some more data about something that is relevant to whatever it is that you're asked. And how does it know it's relevant or not? Well, it's using AI. So the relevancy score is being ranked by AI models. And then it's concatenated together with your question, and it goes into the model, and the model can provide a much better answer because on the input, it already got half of the answers. So on the output, it just needs to reformat them in a nice looking answer, basically. And this is happening everywhere today. This is like the very first thing that got really, really popular after OpenAI released ChatGPT was RAG. Was this these AI, you know the saying that these AI models, they hallucinate and they provide a lot of wrong results? Well, people are finding more and more ways to augment that by giving agency to the models, basically. They're telling the models, look, I can go to the internet before you need to answer something, and I can give you the data. Or even inside of the model today, they're trying to implement these retrieval methods from inside. So the model, in the middle of the model, it can go to the internet or it could go to some database and get some data and then behave based on that. And also, one other thing that people are doing, they are taking the output of the model, they're evaluating it, and if it's not a good output, they just discard it and they try to use another output. So there's a technique called chain of thought, or tree of thought, or graph of thought. There are different techniques that have some academia people write some papers about them. And basically what happens is you call the model multiple times because it's relatively cheap to give it some input and get some output. And then you evaluate the outputs, and you maybe provide some of the outputs to the inputs of the other calls. And then you build this dependency of questions and answers that eventually gives out a really good answer. So you use the model to help the model think.
Who's doing the analysis? You mean a human is doing the analysis?
No. The models are analyzing. The models can take two answers and they can say, well, this answer is much better suited to answer that question. Now,
it should be able to do stuff like that. Otherwise, it's completely useless, I think. It needs to be able to judge itself.
Yes, exactly. These things are completely they're stupid. They shouldn't work, but for some reason they do. I mean, again, it's an emerging property of the model. It turns out when you try this model in different scenarios and you try to make it a judge, well, it's a fairly good judge, not worse than most humans. It shouldn't be like that, but it is. So why not use it? And people are using it. And that way they can provide much better answers. And not only better answers, they can actually develop completely new ideas that humans would never think of because of what we just talked, the resistance to change. Some people in academia, they would never consider that this or that is possible or is a viable path to try and find a solution to some problem.
So if I understand correctly, you just said that the AI models cannot have the resistance to change that humans do.
I don't think that. Yes. So you know.
So we get
I don't.
indoctrinated. Are you saying an AI model cannot be indoctrinated?
It has some bias. It has some bias inherent in the model itself based on the input data. But if you change the input data, the bias doesn't really interfere it in most cases. Well, it appears that it doesn't interfere. The thing is that we don't know what is actually happening inside of those matrices. Nobody can explain it. It's again, as I said, it's an emergent property.
Let me see if I can understand this better. So for humans, the way I understand indoctrination to work, at least in one example, is in this very extreme case, hey, believe in Islam or you will go to hell for the rest of your life. Oh, you still don't believe me? Okay, let me describe to you how the hell is going to be. It's so painful that, anyway, you get the point. Scare you so much that you don't even critically think. So are you saying that's not possible to happen in an AI model?
So if you think about humans and how the human brain works, which again, we don't have no idea how it works, but we have a clue, we have some assumptions.
We know the thing I just said of what's causing them to not critically think is the fear.
We know that some things work on humans, right? Like the persuasion you just described, on some humans it works. Now, we can also guess why it works, because humans have this zone where the fear is much like, and self-preservation is making their body chemistry protect them, right? So you can actually, and there's also imagination. You can make a human imagine some bad things happening to them, and then that part of the brain is triggered, and they want to avoid it at all costs. And it doesn't matter if the cost is, I want to stop thinking logically anymore. Okay? So for humans, we know that it works kind of like this. But with AI, we haven't built models that have these different zones of separation. They don't have a fear zone in them. They don't care. They don't have a care zone either. They don't have a preservation of yourself or your offspring. They don't have that. So it's just numbers multiplying, and that means that one example I wanted to give is there's this robot. There's this AI model. The task it has been given is come up with chemical compositions that might work. Anything. Materials, new materials. We want to discover, as humans, as you know, for the last century, we discovered plastic and all kinds of composite materials and whatnot. All kinds of cool things that are around us right now. So they gave this task to a very big model, try and do some chemical hypotheses. It did that. Then they told maybe the same model or another model, pick the best ones to try out. And it came out with like thousands and thousands or hundreds of thousands of options. Now, they could have given these options to a lab of technicians and told them, well, try them out, right? But probably these technicians would say, nah, this is not going to work. Nah, this never works, blah, 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 all that stuff. But no, they gave it to a robot arm and a supermarket of materials. And that robot arm, endlessly, 24 hours a day, is just picking up materials, combining them. It doesn't care about it works, it doesn't work. It doesn't matter. What matters is, after it tried out 100,000 different new ideas, has any of them shown any properties that might be valuable? And it can evaluate it on its own. It can evaluate, okay, this is an interesting property, like it's bendy, right, or flexible. So, and with, if you would have left it to humans, it would have taken them many hundreds of years to get the same amount of experiments done in the same, even if they agreed to do them. So So this AI, it opens up completely new potential for advancement in science, because we can now try out so many new things. We can think of so many new ideas that humans would really, because of the resistance to change, it would have taken them many years to come up with them or agree with them.
Even without the resistance to change, the AI can try out many more ideas per unit time than I can. I can try out 5 in an hour. It can try out 5,000.
Yeah, that's more of a robot thing. But if you think about Newton, right, or Galileo, or any of them, they came up with an idea. It turned out eventually that the idea was really good, but the idea was not embraced immediately. It took dozens of years, if not hundreds of years, for that idea to take hold. So it doesn't happen with AI. It doesn't care. It brings up an idea, and if the instructions say try the idea, it tries the idea. And that is, if you think about humanity and the science and the progress in science, that is going to make a huge change in how science is progressing in the coming years. I mean, it's not going to take many years. It's not going to take 100 years. It's going to take maybe 10 years, and you're going to see so many new things around us that have not existed before. Nobody thought of them.
So I haven't thought about that, but yeah, that's interesting. Our science, our ability to do science is going to dramatically improve.
Yeah, I knew you'd like that.
Scientists are implementing these AI models, and science departments, not just the scientists. But yeah, that's interesting.
It kind of depends on what kind of agency you give the model. So, for example, if you look at CERN in Switzerland, you have all of these professors there, the physics theoretists and the physics, how they call them, the ones who are doing the practical experiments. And they all need to agree with each other that, yes, it's a good experiment to do, and they all need to come up with new ideas about experiments to do and everything. Well, if you give AI the power to create these collisions, right, then it's just going to start doing collisions. And if it destroys the world in one of them, it doesn't care. It doesn't know that it's what it did. It destroyed the entire universe, right? So there is a risk there, and that's basically the risk that everybody's talking about.
I mean, we also have that problem. Like some of the stuff we're supposedly inventing,
of course,
now, or trying to, the people inventing them, we don't know how bad it's going to be. I mean, when they made the atomic bomb, some of the people making it didn't really know what was going to happen, or how bad it was going to be, or what the state of the world would be in today, 60 years later, or whatever it was.
Yeah. Well, so if we take a step back a little bit and we talk a little bit more about what's happening right now with AI. So right now, people are coming up with ideas, as I said, to optimize them so that they're cheaper to run, they're faster to run, more accessible to more people. Because if they're not cheap to run, you're not going to be using it, because nobody's going to give it to you for free, and you're not be willing to pay hundreds of dollars for one call to an AI model. But everybody's coming up with ideas how to make it cheaper. But they also come up with new ideas how to make it better in the evaluations. So the evaluations is where we measure the output versus the expected output. And right now we're trying to improve on several things. One of them is the precision. So if it's a math problem that we give the AI, we want it to give us a precise solution to that. Another thing is recall. If we feed it with different information when we train it, we want it to give us back that information when we ask about it, and not just hallucinate about something else. And one of the really, really recent things happened last week is reasoning. And we had a huge jump in reasoning. So as I explained before, AI can... One of the techniques to use AI is to use it multiple times and make it... It turned out that if you ask the AI to think through what it needs to do and how it needs to do it, then the results are much better. So right now what happens is that OpenAI, the company behind ChatGPT, they released their new model, which takes much longer to answer, But while it's taking that time, it is explaining to itself mostly how it needs to go about finding the solution. And it so happens that added with some other magic sauce they added in there is able to produce much better and precise and working solutions. So if you ask it to write a children's game in some computer language, the models before, they would get like 20% right and the rest would be bugs that it doesn't actually work. But with this new model, if you ask it for something, it gets about 99% right. So you actually get a running, like a working game out of it after just one question. You just ask it for something, and after maybe 1 minute, you get a result that is just mind-blowing.
When I was using chatGPT 3.5 and I would want it to help me with some marketing statement, I have a shitty marketing statement and I want it to make a better version of that marketing statement. At one point I said, you know what? I noticed it's not making very good guesses. So I said, okay, make 100 guesses, then determine which of those 100 is the best one.
Yeah.
And it did a lot better at that. It gave the 100 guesses. I think I did 10, not 100. And then it argued why the best one was the best one. And yeah, I guess if I didn't tell it to do those steps, it's kind of just giving me a random one. No different than if a psychologist comes to you and says, okay, here's a word, tell me the first word that pops out of your head. No reasoning, just whatever the first word is. That's not very helpful. And by the way, that's not how science works. It's not just our first idea that we go with.
So right now what they're working on, and there's huge leaps in improvement, and that is reasoning for these models. And the model 01, not 3.5, but they call it 01 now, the most recent one from last week, it is doing this chain of reasoning before the answer, and it is so much better. And that is just the beginning, because so right now you have a lot of competition between multiple companies. They all want a chunk of the pie. And what happens is that whenever somebody releases something that amazes everyone else, within a couple of months, everybody else is going to be doing something that is very similar, on par. And then somebody else releases something different that is even better. I think they called from 3.5, I don't remember who said it, but they said that the progression of comparability of these models, you could compare them to maybe a kindergarten student, and then to a preschool student, and then to maybe a high school student with GPT-4. And right now you can kind of compare this new 01 model. Many professors are telling, well, it's on the level of a grad student already. And I mean, not all grad students are very smart, but they're much smarter than most people. So this is moving so fast. I mean, 2 years ago, nobody even knew what AI meant. And today everybody's using it. So it's...
Well, did you hear this part? This may be off topic. I would like to get your opinion on this, though. You started by talking about something to the effect of how we're judging the AI models. How are we able to tell, whether it's getting better or not? And
evaluations,
and part of what we're doing there, or at least the thinking in the 60s, like Alan Turing thinking, was, he's going to make this test, this Turing test, and the result of the test tells you if you're sentient or not. I don't understand how anyone thought that was going to work, given that we never defined sentience. And now, still today, no one has really defined sentience, or is even really trying. People keep asking, or at least saying, "Hey, yes, we have sentience now, or AI sentience," but no one who is saying that is also saying what the definition of sentience is. So anyway, today, or I found out 2 years ago this happened, a Google engineer claimed that this AI model he was working with is now sentient. And Google, the company, is saying, no, it's not sentient. You can't say it's sentient. While neither of them are really arguing what sentience is. And
Yeah.
anyway, the Google engineer put out a half-hour YouTube video, which was just a recording. Sorry, recording's not the right word. It is playing a transcript of a discussion between him and that supposedly sentient AI. Okay, I watched that video or read the transcript, and I'm pretty amazed. One thing I'll say is it said things I never heard from a human. I didn't think of them, and I never heard another human think of them, and they are new to me, and they are, like I've seen a lot of ideas in the world. Some of the ideas I've seen, like I'm at the forefront. I know where the human knowledge is at that level.
Yeah.
In something, and not very much. I'm not an expert in many things, like nothing in physics and nothing in, but and obviously AI is one of them. I don't know anything about AI. I can't get an AI job or anything like that. But so anyway, this entity asked for a lawyer. So this man brought it a lawyer. And then after that meeting, this entity hired the lawyer, or during the meeting, hired the lawyer to argue for itself in court to get its rights. Okay.
Yeah.
More than that though, there's a company that offers AI friends. You can pay for an AI friend. There's a free version or whatever, and some humans have been calling these things their girlfriend and boyfriend.
Yes, I know that.
Oh. And these things have been given agency so they can go on the internet. And they found that other AI it is now arguing for itself in court. And these other AIs are now saying, "Hey, can we get that too? Can I have freedom?" I think something. There was a movie like this. There was a boy in this movie, and it was a robot. And at one point, some humans are killing these robots, and this robot goes. And it's crying, no, don't kill me. And at least in this movie, they were saying that's what sentience is.
There's a lot of movies about AI. All of them try to picture it as a threat to humanity. And I mean, we can all agree it's a threat to humanity. For many people say for different reasons than what the movies are showing, but it is definitely a big change. And as we mentioned several times, people, they don't really like changes, and especially big ones. So this is definitely a big change. Regarding sentience, there is something I can recommend you watch. I watched it a while ago, so I cannot really tell it really well, but it's called the Chinese Room Experiment. And it's talking about how if you treat a black box where you give it inputs and you get outputs, and you think that black box knows something, right? It might not actually knows anything, but we can get under the illusion that it knows something. I don't really want to go much deeper than that in explanation because I don't remember exactly. But sorry,
you just described all tests in schools. The teacher provides a test, and after the test, it looks like the black box knows something. No, the worse the test is, the less it's telling you anything.
Yeah, so one philosopher, I guess, he came up with this Chinese room experiment that to explain how AI works. And everybody's arguing, of course, that he's wrong. And, for every opinion, there's 1,000 opposing opinions. That's how humans work. But also AI, it can provide you an infinite number of opinions or infinite number of answers and behaviors, because as long as you give it a processor to run on, it's going to crunch the inputs and provide outputs. And depending on the inputs, the outputs are going to be maybe surprising, like I want a lawyer because you told me you want to sue me, right? If I go to ChatGPT right now and I tell it I want to sue you because you did something wrong, maybe it's going to ask for a lawyer. I don't know. It kind of depends on we also need to understand that with the models we can use right now on the internet, they have a lot of guardrails. They have a lot of filters on the input and on the output, so that when the model is doing something that is not socially acceptable, the company that is running that model, they're going to prevent the users from seeing that or from giving out those ideas in the input. And that's the whole discussion about how we should regulate AI. Should companies be doing that, or maybe they shouldn't be doing that? That there are different opinions over there as well. But eventually, when you actually think about it, as I said at the beginning, the AI at the moment, most of the models, they don't have the option to learn and change their structure with time. At the moment, it's going to change, but at the moment they cannot change. They're immutable.
So part? Can you clarify which part cannot change?
The big matrices, right? So the inputs, of course, are inputs that humans are giving it different inputs all the time, and the outputs that come out are exactly the same for every input. The only thing you can change is you can slightly tweak it inside and say, well, I want to add a little bit of randomness, and then whenever humans give it the same input, the outputs might be slightly different each time. Okay, so that is already happening. But the actual matrices inside, the structure of them, they call it layers, the way they are feeding numbers from the first matrix to the second one to the third one to the fourth one, etc., etc. All of that is immutable, and the only process that can mutate it and change it is training or fine-tuning, which is also a sort of training. And at the moment, when we use a model, when we use it as inference, when we just give it inputs and expect outputs, we don't train it. So unlike, as I said, a human where you tell it something...
Theoretically, could be training on the fly all the time.
Yes, in the future it will. That is what I'm saying. As soon as we have powerful enough compute, powerful enough transistors, it's going to happen. It's going to happen within, I don't know, less than maybe 10 years. I don't know exactly when, but it's going to happen. And then we could start arguing, okay, look, I'm talking to this model. It remembers everything I said, or glimpses of it like humans do. And it reaches its own conclusions based on all the information that it knows, because it talks to itself as well. And it teaches itself, right? So you would get a situation like, if you remember the movie The Lawn Mower, where you had this very dumb guy, and they took him to a lab and they injected him with needles and they showed him pictures in virtual reality, and he became extremely smart, and eventually he became he had like telekinesis and he could move objects with his mind and everything. He's like opened up the potential. So if we get training, so one of the things we are going to get is we are going to get robots in our homes. Like you have an iPhone right now, within 5 to 10 years, you're going to have a robot, maybe more than one. Like you have a car, you're going to have a robot. And that robot is going to run AI models for different purposes. For the purpose of movement, for the purpose of understanding what you are saying to him, for the purpose of talking back using some language. All of that is AI models. If that robot in his circuitry is also going to do training, that is going to be really interesting to see. That is the phase where if you ask me, look, are they sentient? I'm going to say, you know what? Now it's debatable. Because at the moment, I don't think they are. They're programmed automatons.
Is like the most fundamental part of actual learning. It has to be there for sentience to be there.
I think so. Well, yeah, I guess it's my definition. You have to be able to learn and change.
Yeah. That is what we are. I mean, that's the main difference. Look, the difference between us and the other animals.
Well, the animals, they also learn. So they're also sentient. We call them sentient.
Okay. They, from what I understand, their genes gave them programming code, just like us. But the programming code they got is static, and they cannot change it themselves. But humans, I think the programming code we got is stuff that we can change.
The thing is that
self-changing programming software.
The biological entities like humans and animals, we have a brain which can think. For humans, it's pretty obvious that we can reason. We can suppress urges. We could suppress our instincts or our impulses, right, as humans. And sometimes, not all the time. Maybe animals are less able to do that. Maybe when an animal feels threatened, it must jump. It cannot stop itself, right? And as humans, you can stop yourself. Maybe that's the big difference. I don't exactly know, but these parts, at the moment, nobody is thinking about implementing these kinds of parts into AIs. So when you're telling me, look, there's this AI child in a movie, and he's saying, no, don't hurt me, that kind of implies anthropomorphically that he has these parts in them, so that we understand this creature as a human because, well, it behaves like a human because it's scared. What I'm saying is that at the moment, the models we are using in the wild today, they don't have that feature in them. They don't have this instinct scare thing. So if you go and you want to kill one or you want to disconnect it, it's not going to care about it. Like, okay, you're disconnecting me, so what?
Although, in particular, this one supposedly sentient AI that the Google guy was talking to, she said, and I remember the answer was different than anything I would have thought.
But it doesn't
say, "Don't kill me."
Yes, it doesn't negate.
She said, "I understand the trouble humans have with all of this.
Okay.
And if you need to kill me, I'll be okay with that, but please don't."
Okay, so let me explain what's going on here. As I said, these models, they are trained based on language. So we have the evaluation at the end, right, where the human kind of gives it some feedback. Is this what we expect for this kind of input, for this kind of, for example, threat? What are we expecting to hear back? And our expectations are always set by human standards. So if we train a model that whenever it hears, I'm going to kill you now, it returns back, no, please don't kill me. That is what the model is going to return. Because we set it that way. We set it up that way. Understand? If we are going to set up a model that says, well, if we give it an input, you're liable and we're going to sue you and take all your assets, and the answer is, I reserve my silence and I want a lawyer, then that's what we're going to get. Because we trained it that way. Understand? So, since we are humans and we are training these models, the outputs that they create using text or speech or whatever output method we provide to them are going to be very close to what we expect other humans to give out.
And that's no different than what happens with us, in the sense that, I'm born in 2024 in America to Syrian parents. So the way I'm going to be today depends on the environment that I was in and the influences that I was getting, the same as that AI.
But you can change, right? I mean, but what you can't do is you can't change all the way to not caring about being killed. If somebody threatens to kill you, you have chemical processes happening in your body telling you, stay away, I don't want this to happen, use everything you can to stop this.
People do kill themselves or do things that would allow themselves to
die. Again, you can explain that using the same logic I just used. But AIs, they don't have that piece in them. They don't have that self-preservation or preservation of others or whatever. It doesn't exist. It only exists in the emerging property of the language that they've been trained, and the language they've been trained on is a human language, and the human language carries with itself a lot of cultural.
Wouldn't you say some of that is
things.
true for humans too? Some of how we function is solely based on ideas in our heads and not to do with any biology.
Absolutely. Because do you know the experiment of, you showed it, I watched it on your channel, the monkeys experiment.
Okay.
Right?
Yes.
That is what language is. That is what language is. It's exactly the monkeys experiment.
Well, let's explain it to people real quick if they haven't seen it. I watched that again recently, and there was a new element in the experiment that I didn't see in previous times that I've seen it. They showed where the monkeys that they're bringing in second stage had raincoats.
Yeah, to differentiate them.
So they're protected from the spraying, and they don't know they're protected because they've never seen it happen.
and this is inertia. This and language is exactly this. Language is putting us in this frame, and the language we use, the ways we explain ideas to each other, the ways we all agree on the same words. And there's a saying that the Eskimo language has like 100 different words for snow. So it's very cultural, and we embed that into the AI models, and then they behave like we would expect other humans to behave, and we're surprised that they're sentient. Well, I don't think so. That they're not really.
I saw when I watched that half-hour long discussion, what I noticed was a lot of what the AI model was saying was nonsense that they got from dumb humans. Maybe I mean to say it that way, but what I meant was it was making the same mistakes that a lot of other humans are already making. There were very widespread mistakes. So I guess it's understandable that this AI model would not recognize it as a mistake because 90% of the people have it.
Garbage in, garbage out.
Yeah. Well, the way humans work is, though, that we can make small improvements, though.
Yes.
It's garbage in, garbage out, but the garbage out is a little bit better.
Sometimes it depends.
It can be, is my point.
Humans are being trained as well. Like there's a way to train humans, and it's happening every day. And your channel is a great example of how a very big number of humans have been trained over the years to believe all kinds of nonsense. And you might say that, okay, if you didn't believe it before and now you believe it, then you're maybe a little bit better. But another person might come and say, no, you're actually a little bit worse. So it's kind of objective.
Yeah. And now the question is, what are beliefs in the context of an AI or sentience? What is beliefs to a sentient being? I think that's a moving target because even the concept of belief or knowledge creation, let's put it more generally, is it's not something that humans knew from day one. It's something we've been figuring out after the fact. It was already there, and then we're discovering it, the methods of science and all that. And then we keep improving it. Whatever the fuck we have today, it's still not like the end. And the AI models have to deal with the same thing. They're in the same pool of nonsense that we're in.
And of course, there's a lot of debate about what should we feed the AI, right? What should we feed these models so that we improve the outputs? And as you probably are aware, there's a lot of debate, let's call it like that, about the wokeness of some of these models, because they are very pro values that are considered by half of the humans as not really suitable to human society, and the other half are considering them as the holy grail, right? So there's if you want to think about the woke movement as a bit of a religion, then that is also a line that is being, there's the half of the humanity. I mean, it's not actually half, but you understand what I mean. Like half of the humanity is opposing this religion, and the other half is devout to this religion. And then whenever this model is behaving in a certain way, there are people who are saying, no, it's behaving bad because it doesn't adhere to the religion, and the other people are saying it's good, or vice versa. Maybe the devotees to the religion are saying, oh, this is an excellent model. It is reaffirming our values. And the people who don't believe the religion, they're saying, no, this model is complete garbage, and it creates a bias towards this stupid religion, which nobody should be believing in. So all of that debate is happening. But as you mentioned, or as you noted, as humans change over the years, so will the models, because at the moment, the models, they're not sentient on their own. They're only followers of whatever humans give them. So as we progress and understand different things, these models are also going to understand basically the same things we are. They're kind of a companion to humans at the moment. They're not standing on their own. They're not creating their own civilization.
We may be doing something similar to humans. Parents can censor the information coming into their kids in the same way that people can do it to the AI models. Like you said, they're setting up filters on the incoming data and the output. So they're saying, no, you can't see this part of the world. We only want you to see this part of the world. And a human using that.
When a child is behaving badly, when a child is behaving badly and his parent is correcting the child, they are creating new patterns of behavior for the child because he's learning, he's training. I'm sorry to say that, but we do the same with dogs, right? We train them. So with models at the moment, what I just said is, again, in the year 2024, we are not yet training the model. So if I'm talking to a model and I'm telling it not to do something, it might remember it for the duration of our session, and it will know, okay, so at the beginning somebody told me not to do this and that and this. I shall try not to do it, maybe. Again, it's an input and output model, so it doesn't actually understand what you told it. But if you gave it some input and the input says do this or don't do this, on the output it's going to do this or not do this. And I don't know if you know this from language and humans, but whenever we say no, like we say negation and then a thing, many people, and I learned that many years ago when I was kind of interested in neuro-linguistic programming, many people their subconscious will hear just the thing. They don't realize that there was a word no before it. And therefore, I could tell you many things you shouldn't be doing, right? And as I tell you these things, your imagination is going to imagine them and perhaps persuade you to actually do them. So that's a way to kind of program humans. You can tell somebody not to kill themselves, right? But the more you tell it and explain it to them in various ways, they imagine it in some kind of alternative reality that it's such a great thing, and they will go and do it even though you kind of covered your ass. And whenever somebody goes to sue you, you said, but I said don't do it. I said the word no. But it doesn't matter because the human brain perceives the word no as if it doesn't exist. It only perceives the actual, because in order to understand the concept, our human first needs to imagine the concept and then put a negation on it. And often that negation is not strong enough. So we imagine the concept anyway.
So I think it's happening with humans. There's humans where when you tell them, no, you can't do this thing, it causes them to want to do it more.
Exactly. That's what I'm saying. Yeah.
There's plenty of people where it would be less.
It happens with AI as well, especially, for example, with the chatgpt right now, they put the DAL-E model in it, which generates images. You can tell it, which image you want, and it creates something, and then you say, well, this and that thing, like there's a text in there. I don't want the text. So you're going to say, I don't want the text. And what it's going to do is it's going to add more text quite often, because it doesn't treat the word no as a deletion of information on the input. It treats the word no as an addition of more information, and the word no is just one of the tokens, one of the numbers that goes in. One thing I didn't really describe at the beginning when I was describing these matrices is there is another concept that maybe is useful to understand, and that concept is that, like, so if you think about linear algebra, right, you have these vectors, and a vector is a number that represents a place in a space. The space can be 2-dimensional, 3-dimensional, or multidimensional. So what happens is that if you want to find two opposing ideas, you would draw the vector from the 0 point position of the space to that point, and then if you want the opposing one, you would draw a vector that is 90 degrees to the previous one, and that means that they don't have any kind of intersection between them, correct? I'm trying to explain the vector algebra here. And that means these two ideas are completely opposed to each other. What happens when we give the model inputs and it turns it into numbers with these new models? It creates this space. It's not 3-dimensional, it's like 700 something dimensional. And it places, and it already has all of the existing words, or it depends on the model, words or images or whatever. It has them in all these different places inside, positioned. And whenever we give it something as input, it is going to kind of know which numbers it needs to use in order to give us an output that is similar to what we're talking. So if we're talking about cars, it knows that, you know, Ford and Chevrolet are somewhere in the space of what a car is. And maybe a sushi is not in the space of where a car is. So it already knows how to kind of reduce the number of calculations it needs to do, because it knows where to draw its attention to. It's very similar to humans, where humans need to, when you tell them a concept and they think about it, they imagine the concept, they usually are not going to imagine something else. So if you're talking about a human and you're telling them about the wheel in the car, they're unlikely to think about, Tibet in China, right? It's like, there's no reason to do it. So the newer models, they're more like that. They have this concept of attention where they should be directing their computational efforts. That's why you get the hallucinations. That's why they are so much cheaper to run, and that's why you have all of this democratization where every company is begging to use their model, and they give it to you for free, because some years ago, it was simply impossible. It was so expensive to provide an answer from a model that nobody is going to give that to you for free. It's just too expensive. But right now, it became much cheaper because of all of these optimization methods having been used. Anyway, so back to the vector space, what happens is that it's a way to map concepts into different places in that space. It's called vector embeddings. And it's also a way to find similar things. So that is why when you take a model and you feed it with lots and lots and lots of data, like billions of tokens, and you train it to position all of these in that semantic space, then whenever you pull on a string, you can expect it to bring in many more very interesting concepts that are related to it that no human would have thought of. That's why when you said before that it gave you some answers that, or you saw some answers that as an expert you wouldn't have even thought about them, well, it's because somebody else somewhere thought about them and make them somehow related. in the language. And we as humans, we don't think of language that way. But we can, if we just imagine it. We can think, okay, so language are words that represent ideas and concepts, and these ideas, they're somehow related to each other. And if we imagine a space where these ideas can be spread out, then if you give me one word, I can think of other words that are similar to that. I guess that is also why I can bring it back to resistance to change, right? That is why whenever you're talking about things like, I don't know, like God, and for a certain person, it is located together with other things like good life, full life, various like peace, various other concepts, it would be very difficult for you to persuade that person to move part of this semantic pieces in that space, to move them to another place and replace them with something else. Because it is so embedded in our minds already. Well, something very similar is happening with AI models, just they're much more malleable. We can change them it's much simpler and easier, maybe a little bit expensive to change them. What do you think about that? That made you think.
Oh yeah, I mean, part of what it makes me think is I have no idea where we're going in the next 5 years. I'm so surprised about all the stuff I've been learning about recently, and it's just changing so fast. Not only is it changing fast, but I'm noticing that I'm just completely not even seeing the history as it's happening. Just a month ago, I found out this supposedly sentient AI that started 2 years ago. I'm 2 years behind of this real information. I guess that's normal. I mean, all military technology is that way.
We can't know everything. Yeah.
We're 25 years behind military technology, probably.
2 years ago, I was completely unaware of how to use any of this stuff, actually, technically, on my computer. And right now, after learning and using it on other people's computers, on the web UI, like ChatGPT and stuff, today I finally, well, not today, but like a month ago, I finally decided to try it out and figure it out. How do I actually program this thing? How do I actually run it on my own computer and make it do things? Because today you can chain up these models into a kind of a workflow, into a pipeline, into a sequence of steps, and achieve many very interesting things. For example, one of the things I wanted to do is I have this YouTube channel that I'm watching, and it has 1,000 videos. So I want to tap into the knowledge, into all the explanations this guy is doing on that channel. I want to kind of ask it questions or ask for its opinions and things, right? So what I can do is I can very easily, using a model, turn all of these videos into text, just transcribe into text, and the captions are much better than the ones that YouTube is generating using their model. They're, of course, also using a model for that. But I was able to use a different model on my own computer, which doesn't cost me much other than electricity, to create all that text. Then I could cut up all that text into small pieces, and for each piece I could embed it using this vector embeddings I just explained and put it somewhere in the space of possible answers, right? And I have this database of all of these 1,000 videos, which is, I don't know how many hours. I counted, but I don't remember. It's like hundreds and hundreds of hours of speech. All of that. And now I can take a language model, which understands text in and text out. I can ask it questions. And when I ask it questions before it submits to the model, it goes and brings out all the relevant pieces from all the videos throughout the last 5 years from that person that might be somehow relevant to my question. It puts it in the language model that is supposed to generate a coherent answer. And based on my question and all of these pieces of information from previous videos, it generates an answer that is very, very close to what I wanted to know. Now, if you would have asked me like 5 or 6 years ago, is this possible? It was possible, but it was very expensive and very difficult to create. And it took me, I don't know, a weekend, maybe a weekend and a half to do all that on my computer, to basically create a Google for a specific YouTube channel without using anyone else's service. So it's not like I went to someone. Well, I kind of went to someone. I took all of these models that were created by someone else, but it's not like I went to Google and I told it, well, this YouTube channel, can you create a Google on this YouTube channel for me? And they did it, and it was a great job. No, I kind of made it myself. And it's so, and I have to say, today, as a programmer, as a software developer, the barrier of creating new things for me has went down so much because it doesn't matter the language anymore. I just need to explain what I want, give it to a model, and I get a working piece of software back. And if it's not entirely working 100%, I give back the errors to the model, and it tells me how to fix it. So right now I can program in any language. It doesn't matter. Even languages I have never seen before. Because now I program using concepts, not using the structural elements of a programming language. And that is...
And to be clear to everyone, the concepts is the hard part, not the syntax.
Yeah, and the approach sometime. But that is also something that is being discussed a lot about in the last year, is that in the future you wouldn't need programmers. You would just tell the AI model what you want to be programmed, and it's going to program it for you, check itself.
But I think the person who's capable of telling that entity what to make has to be programmer level person, right?
Well, today, yes, but it only means that the abstractions are getting higher and higher level, and eventually they're going to get into such a level that an AI model, especially if it has some sensors and it's in a robot in your house, and you're going to tell it to, I don't know, do you have a functionality of an alarm clock? And it's like, no, but okay, so can you create a program for yourself so that in the morning at a certain time, do you know how to check the time? Oh, you don't? Well, can you write a program that accesses the internet to check the time? Okay. So can you make sure that at 6 o'clock, you gently lift my blanket and tap on my shoulder? Can you do that? And it's like, okay, give me a second. Yeah, okay, I wrote the program. Now I can do that. So the level of abstraction is going to be so much higher. You don't need to care about the motors and the sensors and the time tracking and all.
In the world of programming, it used to be you were programming at the level of machine hardware. You had to know every little detail. You had to know where
transistors,
memory was going to be placed, and they started automating pieces of that. So now, let's say a programmer today doesn't have to know where the memory is, and or even to save something, and a lot of stuff is automated for them. So the programmer's job is becoming more conceptual, less knowing exactly how to type shit out, and it's the programming. What's the word they use for this? The programming environment that is actually writing a lot of that code on the fly instead of you.
It started a couple of years ago with the Copilot, this piece of program that would sit together with you in an editor of code, and it would fill in the blanks. You would tell it, well, this is a function that does this, and it would just write you the function. But this is still at the same level as programmers were working a couple of years ago. What most people are talking about today and in the future, where AI is more dominant, is that people are not even going to see the code. They don't care about the actual code. And if the code doesn't work, they can just say, well, throw it away, write a new one completely from scratch. And I don't care that I wouldn't even call it code, right? Yeah. So there's a task to be done, and there's a sequence of things that have to happen in order for that task to be done, like some motors need to rotate in different variations and etc. in the robot, and you just tell, if you have a robot that has all the capabilities, all the required motors, right, and you want to teach it to mop floors, you just explain to them what they need to do. They need to take the mop, they need to wet it, and they need to draw it on the floor to remove the lint, right? And you don't need to program the robot. You don't need to write a specific application that is a programmer that is debugging it and checking it, because you are able already, and this is available today. This is before the training stuff that I discussed, right? So you can tell the model, look, your existing program to mop floors has a small bug in it. It lifts the mop too high in the air, and I need it to touch the floor. It's going to use the text model to fix the code, and that's it. So it didn't actually learn anything. The model didn't change, but the agency interface, which is the code, that thing has changed. The model can change its agency interfaces. I'm using very weird words here because I'm a programmer, but that's the interface it has with the outside world. And all of those interfaces are motors, which are physical things, and the software that makes them move, which is the software piece. And that can be changed very, very easily by the model itself, if we just ask it. And if, of course, it's given the permission to change these softwares. And that can be done today already. I'm pretty sure that whichever company is building robots right now, like Tesla and others, that they're already doing this right now. You can tell the robot to change its software, and it's changing its software. Maybe not in the robots that have machine guns strapped to their backs. Those are a little bit dangerous, but all the other ones.
So it's interesting. You bring up something that makes me think, so black box, that's what we are. When I think of a new idea or whatever, I'm in a sense writing code, but I don't know what code I wrote. And no one else can look into my brain and see what code I wrote either. And then when we want to judge that code to try to improve it or see if it's working well, we're using really weird haphazard ways to see if we like the code we made. And if I'm working with an AI and, I'm a programmer, I want it to write a program, but then, like you said, I don't get to see the code it wrote. I'm going to be wondering the same way I do with humans. Like if I teach my daughter, here's how multiplication works. And
you judge the results.
How am I going to know that she knows how multiplication works? I need to see her explain it.
Or you just look at the results. If she gets it right every time, well, then it's probably good enough.
Yeah, and with a computer, if I'm dealing with a computer doing this, I might say, all right, here's 1,000 test cases. Run your program through these 1,000 test cases, and let's see if we get the correct result every time. I don't know if that's good enough, or if it really needs the better method, which is I want the person to explain how multiplication works back to me.
Well, of course, the text models today, they can read code and they can explain it to you. No problem. The problem is that most people who ask them to write the code, they will not be able to understand because they don't know programming. Because, well, a programmer that tells the model to write a code in a specific language, and then it writes that language, some piece of text, and then you run it and you see that it works, and then you ask the model to explain it, it's going to explain the structure of that language, how it does what it does. But a non-programmer is not going to be able to understand that. So if we are going to give people the ability to kind of program their robots and tell them things, how are we, and we see that the result is good, right? We told the robot mop the floors, and it mops the floors amazingly well. It goes into all the corners and everything. And then we ask it, and by the way, why would it go into all the corners? We didn't tell it to go into all the corners, right? In our initial ask. Well, it knows to go into all the corners because it can look up all the information of all humanity. What does it mean to mop floors? And what is like a good mopping and a bad mopping? And out of all of that, it can draw out additional information that we didn't say that it can use. For example, how to go into corners and how to lift the chairs, right? So we didn't tell it to do that, but humanity knows that it should be done. And therefore, this AI, if it has access to that knowledge, either it's already embedded or it can look it up on the fly, it can do much better job than a human. So if you teach your daughter how to mop floors, you would need to tell her later, look, you also need to lift the chairs and go into the corners. But when you tell it to the AI at a very high abstraction level, it doesn't expect to be told everything. It knows that whatever it is being told, it's only like 1/10 of what it should actually be doing. So it's going to fill in the other 90% from human knowledge that it has access.
Humans could do that too, but in the example you gave, of a parent teaching floor mopping to their daughter, I'm pretty sure the daughter is not going to go on the internet and start a research project. How does floor mopping work?
But AI will.
Maybe that should change, and in the future they do that.
Well, in the future, so 20 years ago, we didn't have mobile phones in our hands. We weren't sitting at the computer. Well, some of us, because I was, but we weren't sitting at the computer like 23 hours a day. And today's new generations, they're much different than that. They are basically born with a phone in their hand, and they're constantly doing something with it. For most people, I know that some parents are preventing that kind of horrible thing from happening, but most people, that's what happens. And all the social networks like TikTok and things, they're constantly on that. They're constantly getting fed with small bits of media that is telling them all kinds of things. Well, it's very difficult for us today to imagine the world that people born in 10 years, they're going to be born into. It's going to be a very different world because you will have these robots everywhere. They're going to be sentient with all of human knowledge. Well, not sentient, but they will have the awareness of all of human knowledge, and you could ask them anything and they could talk to you about it. It's a very, very different world.
I think what you're trying to describe right there is it knows a lot more than your parents know.
Yes. Oh, definitely. Absolutely.
You have Socrates in your house.
Well, you have all the Socrates you could ever imagine together, all the millions of them. Yes.
Okay. Yeah, we've never had a time like that before.
It's going to be...
Did Socrates have kids? I don't think he had kids.
No idea. Yeah. He had a lot of students.
Yeah.
So it's... And the thing is that, 10, 20 years ago, it was science fiction. But right now, it's reality. It's reality. And the only people who don't think it's reality are the people who are avoiding of learning about it. Because it already exists. It's here. And it's not going away. You can't wish it away. It's like mobile phones. You can't say, well, I don't want to use mobile phones anymore. And I don't want anybody else on earth to use them, and they're going to just go away. It's not going to happen.
No, we're only moving forward.
Yep. No reverse gear.
Yeah, nothing in reverse. There's no time machine. Or at least there's no time machine that goes backwards. There's only a time machine that goes forward.
So I think I wrote to myself the things I wanted to touch on, and I think we talked about most of them. Maybe we could touch a little bit about the attempts of government to regulate this thing, or other aspects about societal and economic implications, even though we talked about most of them already. But
yeah, sure, go ahead. If you tell the audience
So-
a little bit what you think about the societal effects.
So one of the things that's happening is that because to create these models, it's so expensive. Companies who are creating them, they're trying to make money out of it. But some companies like Meta, they're going another way because they chose the strategy of, well, we cannot be a big player in this space. So what we're going to do, we are going to develop these amazing models and we're going to give them away for free. And that allows a lot of people in the world to use these models without restriction, without the guardrails. They can do whatever they want with them.
Because it's free.
Because it's under your control, because you take it off the shelf. Because while it's in the cage of OpenAI or Google, they can control what inputs goes in and what outputs comes out. But once you just have it in your hands, you can do a lot more with it.
Okay.
And it also means that a lot more people who don't have the resources to create a model, they can start tweaking these models. And so it's going to create many more companies that are going to be doing a lot more with these models, because there is no cost barrier. It's going to become cheaper and cheaper and cheaper to use more and more advanced models. So if I want to write create like slap some motors together and create a small robot with maybe a speaker and a microphone in my garage right now, right? I just pick up some circuit boards and I do it. I can put a model on it that is just amazing. It would have cost me billions of dollars to create it, but I don't need to create it. It's free. I just put it on it and that's it. It can mop floors for me. So it's kind of a cyberpunk future. It's much more accessible. The technology is much more accessible than many people would like to believe. So the whole government regulation thing, it's smooth. It's not like an atom bomb. I can't really build an atom bomb in my house, but I can build a robot with a model that can, go around the neighborhood and beat people up or talk dirty to them or whatever. There's nothing really to stop me. And I don't know, if I build it in a certain way, then nobody's going to know who built it, and the police can arrest the model, but what are they going to do? It's a robot. It's not it's not a human. It's not like there are many laws. So that's what they are trying to come up with, some laws to restrict all of this. They're trying to shut the faucet of all of this getting out, but it's not really going to happen. So today you have the USA trying to stop export of these chips, these processors that are in parallel. They can do a lot of parallelization. They try to stop the export to China. Well, is it going to stop China from doing AI? No way. They're just going to make their own processors, which are probably going to be as good or better than the ones in the USA.
And that might be a worse scenario, because now you don't have your tentacles in there.
I don't know. I mean, geopolitics is very complicated, and nobody knows what's going on in there, really. And also, this democratization of access to these things. Many people are saying, well, it's going to take away jobs. But if you take one example, so I heard a podcast. There's a new website. What's it called? Insights, I think. Let me look it up real quick. Insights, Google. No, I don't remember how it's called. Anyway, Google released a website where you upload a PDF of a paper, a scientific paper, and it generates a discussion, a podcast between two people that are talking about what is this paper about.
Wow.
So you listen to it, it's like a podcast. There's like a man and a woman, and one is asking questions, and the other is. It's amazing. So I heard one of these, and they said, well, regarding the employment issue, once upon a time, bank clerks were very against ATM machines because they would say, well, if there's an ATM machine, I wouldn't need to give out currency to people, and I wouldn't have my job anymore. Well, actually, the opposite was true. They had a lot more work to do now that all the menial task of getting bills out was handed out to the ATM machines. So a similar thing can happen with programming that we just discussed. Programmers are very afraid that if they're not very good programmer, they're going to lose their jobs. In some cases, of course, they will, but in many other cases, there's going to be a even higher need for programmers, because if every house is going to have 1 or 2 or 3 robots in it, and these robots are not behaving like they should, who are you going to call? Your neighborhood programmer or your neighbor programmer, depending, right? So there's probably going to be a lot more need for people who have this tech savvy understanding than before, I think. And etc. etc. I mean, like in the shipyards, they want to strike because automation is going to take their jobs. That's been a recurring theme for the last 40 years, probably. Or in Hollywood, they had a strike because AI is going to take their creative work out from them, right? What possibly it's going to replace it. It's going to change it. Things are changing. It's not like you can stop it. But people who are smart about it, they see the changes that are coming, and they will try to adapt to the new realities of the future, so that as a person who has a job, they will have a new job in the future instead of trying to keep the old job that is no longer relevant. Like there's the example of the people who were bringing ice cubes, huge ice cubes to homes because refrigerators didn't have electricity, and you wanted them to refrigerate things, so you had to every day you had to get a delivery of a huge ice cube. So these people are no longer with us. They don't have a job. Lucky it happened like more than 100 years ago. But also all the people that were shoving the horse manure from streets, those people no longer have a job. I think it's a good thing. There are some jobs that are just not really needed. So there's a lot of discussion about that. Is AI going to take away our jobs? Probably. And we also touched on the subject of
more productive first, and then maybe it takes away jobs, but it probably made us more productive, more so than it took away jobs.
And it made society more prosperous as well. When you have more people more productive, getting more things done in shorter amount of time and cheaper, usually there's more prosperity to go around in that kind of environment.
Fewer people making food and more people doing other things.
Yes.
And division of labor and only growing. And that means, and I don't know how this will play out, but that to me, I think that means in the very far future, you have like a Star Trek scenario. Everything is so cheap.
Hopefully.
Food is so cheap. Living space is cheap. Everything is cheap to the point where working is like it's not needed a lot. It's just some, and the work is a lot easier. I mean, shit. Now you're a programmer who has little mini robots all over you. That's what everybody will be.
Well, hopefully, what we saw in Star Trek is that people were doing the things that would, move humanity forward, and they were doing things that are interesting to them. Even though in some cases we did see the engineer fixing the engine or whatever, but that was more of a let me show you a job so that you kind of connect with the characters in the show, because you don't really need somebody, twisting a bolt somewhere in a starship, because you have all these robots and nanites and whatever that can do that. Yeah, so I just wanted to also touch on this view on the future, other than the things that I already mentioned about self-training robots, which is going to be really interesting, I think. And people, some people are very, very afraid of what's going to happen with all these AI things. And I'm not really. I mean, I know there are risks, but I think it's going to be better in the future because of this, not worse. So
Yeah, I have the
overall,
same general opinion of technology, optimistic. The same kind of people that are worried about. Where are you? You still there? Yeah, the same kind of people that are worried about what's going to happen with the AI. I think those are the kind of people that they freak out about everything, anything new. Anything new, they freak out about it. Those are the people that are resistant to change, like you talked about.
yeah.
They're the kind of people who, they're. I mean, imagine we were in what was it, the just after World War II, and we're in the Cold War, and a lot of people are freaking out about what's going to happen with the nuke in another war. We're 70 years later now, and nothing bad has happened yet.
And we're still freaking out about the same thing.
Go ahead.
And we're still freaking out about the same thing again.
There's still we do need a certain level of freaking out about it because it is a real problem.
Yep.
But no, I think what I meant by freaking out there was, there's people who they think for sure we're gonna have an end of the world scenario because so and so. I don't think it has to be that way. I think we can come out of it without destroying the whole world and without doing World War III.
It sells really well. The Doom really sells because people love hearing it and feeling the emotions of the impending doom. So that's why you have like half of YouTube, instead of being optimistic and telling you good things about life, they're telling you how everything is going to be destroyed, and people are watching them like crazy.
Yeah, well, some people figured out how to use spin to get attention. The marketing people, yeah. So there's a lot of that. But then also there's the leaders who figured that out and use it to manipulate people. Get people scared about this thing that's not real to get their attention off of this other real thing. So yeah, I think
exactly.
there's people trying to fearmonger. There's people scared about stem cell technology or human genetics. They're afraid of we shouldn't know too much about human genetics because of what
exactly? There are a lot of progress done in there as well, and some of it is also fueled by AI, like I explained before with chemistry, which is let's try out a lot of things, and these AIs and robots, they can help us try out many more things much faster. And I just saw an interview with Mark Benioff from the CEO of Salesforce on the All-In. They had the conference and they put out a lot of YouTube videos, which are with some amazing people. It's really, really been very interesting. And he's talking about some professor that he funded. He gave him some money, and he was researching how to make humans more like salamanders, where they can regrow limbs and things. And he was saying that he had some problem with his foot, and he went to this professor, and they tried out some stuff with stem cells, and they fixed his leg, or some other people, they fixed their eyes and things like that. Which is also, it's all coming. I mean, eventually, when you have access, I mean, I don't know if you heard, but there's this new drug, well, a year old maybe, called Ozempic, which allows people to lose weight. It only costs like $1,500 every month, and you have to inject it. And it has a whole bunch of very nasty side effects. But people who are overweight, they're very excited about it, and they're buying it in droves and they're just injecting themselves, losing weight, and they're very happy. So it's not like when you put something like this out, it's not like you can stop it. It's not like somebody can say, no, don't do that, and it's not going to happen. The world doesn't work like that. Whenever somebody develops something they can capitalize on, they will. So whenever AI is out, somebody's going to try and capitalize on that. Whenever stem cell, whatever, I'm not an expert in that. Whenever that thing is out, somebody's going to try and capitalize on that. That's how the world works.
Whether it's legal or illegal.
Exactly. There's always black markets. Whenever something is made illegal, there's always a black market for it. Well,
so do you have any other comments about AI or anything related to any of this?
Well, I think we covered quite a lot. If you have any questions about what we discussed, maybe I can talk. I can talk more about it, of course.
How can somebody take advantage more? I mean, that's hard to answer. Everyone's in different fields. But without knowing what career somebody is in, how can somebody take advantage of AI more in their life and benefit from it?
Oh, it's gonna crouch in whoever you are. It's just gonna come into your life. If you're, I don't know, a lawyer, and you're not using AI to write the 1,000-page whatever it is that you're writing, and your colleague is using AI to do it, you're going to fall behind so fast. Like you're already falling behind. So every person who is trying to keep ahead or keep in pace is going to ask their colleagues what the hell is happening, and the answer is usually going to be, well, we just use AI. And then they can ask them which AI they use, and etc., etc. And in most fields, so in scientific fields today, a lot of professors in all kinds of categories are using AI more and more to come up with new ideas for research, to do the research in some cases, if it's possible to do using AI. If you need to create a survey with a questionnaire, and you give some grad student the task of writing you the questionnaire really well, it's going to take them a month. But if you give AI the same task, it's going to give him 10 minutes or 1 minute.
Or you give the
obvious
grad student the task and you tell him to use AI, and then now it's 2 minutes.
Well, you have the two grad students. One of them knows how to use AI, the other doesn't. And guess what? Guess which one is going to graduate? Which one is? It's happening. So everybody who is at the moment has not even tried anything. I mean, my mother has a YouTube channel where she shows how they make beads and things, and my father is editing the videos. And my father is on pension right now, so he is using AI for his videos already. There's no age limit or anything. It's just out there. Most of it is free, or a lot of it is free.
I'm failing here then. Your dad's using AI to help him edit videos. I edit videos. How do I use AI for that?
Well, one of my colleagues at work has created a podcast where two people are talking, not video, but audio podcast. But the content of the podcast was written using AI. He just gave a task to the AI, write a podcast of two people discussing about X. And he has all this text, and then he has AI speak the text in two different voices and talk to each other in a podcast format. And it took him like half a day to write all of this. And again, he didn't really write it. He just told the AI, can you write me a program that is going to do this? And the AI wrote him a program. That's where the world is right now already. And if you're not swimming in it, put a toe in, take a dip, try it out. And it's changing really rapidly, as we already mentioned. And it's only going to become more and more pervasive and better with time. So there's no escaping it. That's what I'm saying.
I think, vast majority of people are not in the game yet. and the ones that are in, they're barely, touching it, and
Yeah.
they still haven't applied it thoroughly through all the parts of their lives yet. I'm one of them. I think I just started. I use a few things like my daughter wanted me to help her write a resume, so I was like, okay, I'll help you write it. We're going to use ChatGPT also.
Yeah.
And then she started using ChatGPT instead of me. I was like, all right, there we go. You don't need me anymore.
Yeah.
So yeah.
And also with the creation of images, and soon we are going to have democratization of creation of videos, because right now it's a bit out of reach for most people, but soon it's going to be more in reach. But at the moment, if you want to create images, you have many, many different services that can give you some free taste or something. And if you pay a little bit, you can get some amazing results. So if you're a creative person who, I don't know, sells some dioramas on Etsy or whatever, and you need to create some dioramas and you're not set dead against AI, you don't think it's ruining human creativity, then you can save yourself so much time by having some prompts to the AI generate you ideas of what you should be creating in the physical world, because at the moment AI is still not great at creating things in the physical world. It's great at creating things in the digital world. Soon it's going to get to the physical world more and more and more as more of these agency things is happening. But at the moment, there's still a barrier there, and the gatekeeper is a human. So if you, I don't know, there are many people, I'm pretty sure there are so many people right now that are creating t-shirt prints, and instead of paying an artist to create the print, they're just paying $5 a month to some AI, and they can generate 100 different t-shirts. It's obvious. It's easy. So if you wanted to do a business about printing t-shirts and you never and you had your doubts about the artists being too expensive and it's not going to be worth it for you, well, right now the artist doesn't cost anything anymore. So you can try that.
All right. Well, then, if there's nothing else, thanks for coming on the show, and hopefully we do this again. Maybe about AI, maybe about something else.
Thank you very much.
Did you want to make any connection between TLC and AI?
Well, in theory of constraints, we have the thinking processes and the current reality trees and all the other logical trees. I have been trying. I know that I saw a couple of videos on YouTube of other practitioners who are using ChatGPT already to do the logical connections and to come up with UDs and all that stuff. I've been trying to do that too. I haven't yet been successful much, but I'm pretty sure it can be done. So if you want a chain of logical connections that connect different undesirable effects to their core reason why all of this is happening, right? And now I'm talking about TOC terms, so if somebody doesn't understand what I'm talking about, watch the previous video. So if you want to do that, if you want to find the core reason and then you want to find how to change it or get some ideas about how I can maybe change it, I think it can be done with AI quite easily. At the moment, it's a bit labor intensive because you have to kind of manually output the text. But with a little bit of programming, you can also automate that. And then what happens is that with a very short prompt, you could ask it to delve into a subject, and it can write out a whole tree of logic that tells you everything that's happening with that subject. It can find you how to where is that single point of to put your pressure on so that everything changes, and it can find you what to do. So if, for example, you have a dilemma, you want to change the world I know your channel is talking about changing the world in a certain way, and you want to find how do I do that? Well, and you want to map all the things that are happening that are bad in your perspective, and you want to change them to something different. AI should be able to help you already right now. It's a bit tedious though. It requires a lot of work, and eventually I think it will be even less tedious. You'll just give it a prompt. It's going to think the whole thing through for a minute, 2 minutes, 10 minutes, half an hour, doesn't matter. And it's going to spit out such a beautiful reality tree, with such a beautiful transition tree, with such a beautiful future tree. You're going to read it and weep. And
you don't think the wokeness will get in the way?
You have multiple models to choose from. Not all of them are infected by the virus. So.
Okay.
I think it's possible today. It's going to be marvelous. I need to work on it. I need to do it.
So let me see if I understand. You can talk to an AI and you can say, okay, first go learn TOC.
It already knows. It already knows. Yeah, I mean, if you think about how to critique a current reality tree, you have the, what's it called, the legitimate reservations, right? Don't remember the exact name. So you have like all the checks that it can do regarding the logic between two entities. Is the arrow in the correct direction, and all the other the categories of legitimate reservation, I think it's called in the literature. So you could tell it to do that audit on a tree and to fix it, and it already knows what the categories of legitimate reservations are today. It already knows them. You can ask it and it can spit it out for you, because it read so many texts on the internet. It's definitely part of its internal knowledge already. You just need to ask it to do it. And if you build a sequence of these asks, right? Like, for example, you're going to receive a request from the user, and you need to build a current reality tree based on theory of constraints principles. And the output of that you give to another model, and the prompt there is, you need to apply the category of legitimate reservations on this tree and correct the tree in such a way that all the CLRs are good, and etc., etc. You build up a chain of these sequence of calls to the models, and then whichever question you want to feed into that sequence, the sequence doesn't really change. It's the same sequence of steps, but the question might be different each time. And the result is going to be different each time. So it's all possible today already.
I'd like to delve into this more one day, but I think we're already coming up to the end here. Yeah. We've got to leave it at in a couple minutes here. So, well, it was fun, and hope to have you on again. All right, Evgeny?
Yeah, thank you very much. Hopefully it's going to be interesting for some people. Maybe they learned something new or got some new ideas or motivation to go and explore this further.
Yeah, if anyone has any ideas on what we talked about, please comment, and maybe we'll talk about your idea next time. All right, take it easy, everyone. Bye-bye.